So in this video, we're going to look at the idea of the complex conjugate. Now in the last video, we looked at the complex number z equals a plus bi. A and b are real numbers, and a and b belong to the reals, and we saw that a is the real part, and b is the imaginary part, bi is the imaginary part. Now the conjugate of that, z with a bar above it, is plus a but minus bi. Okay, so if the original complex number z is a plus bi, then the conjugate is a minus bi. And through the use of conjugate, we can realize a number, we can perform certain operations. So the conjugate operation is an important one, and it will work out to be a rotation in the opposite direction. Okay, and we'll come to that shortly. Okay, so its conjugate has many uses in the algebra of complex numbers, but also in relating to the angles as well. Okay, so let's have a look at some properties. Number one, z plus its conjugate, a plus bi plus a minus bi. Notice the imaginary parts cancel out. Plus bi minus bi cancel out, and we're just left with 2a. We're left with a wholly real number. So we're left with the real part here. So the use of conjugate will have interesting uses. Z times the conjugate of itself, the complex number z times the conjugate of itself, is a plus bi times a minus bi. And if you expand out the parentheses there, you'll have a squared minus abi plus abi. Okay, you can see those two cancel out, so they're gone. All right, and you're left at the end here, minus b squared times I squared. Now we know that I squared is equal to minus 1, and so this becomes plus, and we're left with a squared plus b squared, a wholly real quantity. Okay, no imaginary part to it. So again, this complex conjugate has some interesting uses. Now, another thing, if we have two complex numbers added together and then we take the conjugate of the whole result, that's the same as conjugating each of the original individual complex numbers and then adding the result. Okay, if we conjugate the product of two complex numbers, that's the same as conjugating the individual elements and then multiplying the result. Okay, so it's the product of the individual conjugates is the same as the conjugate of the whole product. Okay, if we take the reciprocal, and by that minus 1, that's what I mean, so I'm talking about 1 over z. Okay, so I just meant it as a reciprocal. Then the conjugate of z, taking the reciprocal, is the same as the conjugate of the reciprocal. So it doesn't matter which order we do those operations, in the outcome's the same. In future videos, we're going to look at the polar form of numbers, the polar form of complex numbers, but essentially the conjugate is simply taking taking theta, the angle, and replacing it with negative theta, and we'll explore that in future videos. So let's look at some examples here. If we've got example 1, z1 is 12, okay, it's wholly real part, then the conjugate of z1 is just going to be conjugate of 12, which is just 12. Nothing changes. The real part's not affected by the conjugation operation. z2 is 3 minus 2i, then the conjugate of z2, this next complex number, is conjugate of a whole lot, which is 3 minus 2i. Conjugate of that is 3 plus 2i. The only thing that changes is the sign in front of the imaginary term, the imaginary part. Z3 is minus 5 plus 6i, then the conjugate of Z3, conjugate the whole lot, is still minus 5. The real part's not touched, it's only the imaginary part that changes sign, and it becomes minus 6i. Okay. Some examples here, Z1 plus the conjugate of Z2 plus the conjugate of Z3, well, Z1 is 12. The conjugate of Z2 gave us 3 plus 2i, so 3 plus a 2i here, and the conjugate of Z3 was minus 5 minus 6i, so we have the minus 5 and the minus 6i. When we add all that together, collect all the real parts, 12 minus 2 is 10, 2i minus 6i is minus 4i. All right. One other property, and I think that finishes the video. A complex number times its conjugate is the same as just mod z squared. Okay, and mod z squared is multiply out the brackets again and perform the same operation. You'll see what happens. Okay, we'll pick that up later though, but just one of the basic properties here: z times z bar is mod z squared. All right.